Okay, so the directions to this one was to write with sigma notation an expression or a formula for this series. So again, we know the answer have to have a sigma. The dot 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 means it's going to go on forever, so we know the top is going to be infinity. What I have to do is come up with the equation that goes there, and n equals some number, usually 1 or 0, but sometimes it comes out to be something different. So the first thing you start doing is you start looking for patterns, and you figure out that it's a multiplication pattern to get from one term to the other, and it's negative 1/3 each time. And if you test that using your calculator, you'll find out that indeed that is true. So basically we know T1 equals negative 9. We know that the R, or the multiplier, is negative 1/3. And we know a general formula for a geometric sequence. Do you remember what that is? So the formula is T sub n equals T1 times R to the n minus 1. And we can test that. We can go negative 9 times R, which is negative 1/3, to the n minus 1. So if I want the first term, I go 1 minus 1 is 0. So negative 1/3 to the 0 is 1 times negative 9 is negative 9. It gives me the first term. I can try it for the second term, so I let Tn equal 2, and it works. So, so the equation seems to be T sub n equals negative 9 times negative 1/3 to the n minus 1. And most of you put that answer on your paper for homework. And when I check it, right, and I check n equals 1, for that, I get the first term. I'll check n equal 2. I'll check n equal 3, just to make sure that it works for at least the first 3 terms. And usually if it works for 3 in a row, it works for all of them. And okay, so now you can see I put the book answer down here. The interesting thing is, how can we get our answer, or how can I get the book answer? So I'm going to show you how to go from our answer to the book answer. I'm going to clean up the board to give myself a little space, and then I'll... Alright, so I'm going to show you how to get the book answer from our answer. So let's start with our answer here. So we had negative 9 times negative 1/3 to the n minus 1. And this is just really important exponent know-how that you should be able to do. So let's see how we can rewrite these problems. So using the exponent rules, I'm going to rewrite negative 1/3 to the n, negative 1/3 to the minus 1. Now, remember, if the bases are the same, I add the exponents. So if I add n and minus 1, I get n minus 1. So I'm going backwards using the exponent rule. Okay? Now, the next step is I'm going to rewrite some of these. For example, the negative 9 could be written as negative 1 times 9, or 1 times negative 9. I'm choosing negative 1 right now, and you'll see why in a minute. But you can always try it both ways, see which works for your particular problem. Negative 1/3 to the n, I'm going to leave alone. All right? And negative 1/3, I'm going to rewrite as negative 1 times 1/3 to the negative 1. Next step, going to keep everything the same here. Going to keep this one the same. Now I'm going to rewrite this one, negative 1. The exponent on this 3 is a 1, so I can move that 3 to the top of the fraction and call it 3 to the negative 1. You with me so far? So basically, I'm changing one thing at a time. Now, I'm going to rewrite this as negative 1 times 9 times negative 1/3 to the n. And then I'm going to write this as negative 1 to the negative 1 and 3 to the negative 1 to the negative 1. You see what I've done? I've just separated this. They're both to that exponent. Again, using exponent rules. Now, every time I do a step, I keep looking at where I want to go. That's the book answer. I'm trying to get my answer to look like the book answer. You notice this negative 1/3 to the n, that is in the book answer. So that part I don't want to touch. All this other stuff I'm going to try to touch or do something with. So this negative 1 doesn't have an exponent on it. I can put a 1 there. I can put a 1 there. Do you agree? 9 and 9 to the 1 are the same thing. Negative 1 and negative 1 to the 1 are the same thing. Now I'm going to group things in terms of stuff that has the same base. All right? For example, this base is negative 1 and this base is negative 1. Do you agree with that? Okay, and looking at other things, I'm going to write this 9 as 3 squared because then it will have the same base as that. So let's rewrite this. Negative 1 to the 1. Negative 1 to the minus 1. I'm going to write this as 3 squared. 3 squared to the 1. Negative 1/3 to the n. Remember, I didn't want to touch that. I moved this to the front here. And then this 3 to the negative 1 to the negative 1, I could call that 3 to the 1, right? Because power to a power, you multiply exponents. Now, do you see that I have some same bases here? I have, well, 3 squared to the 1 could be just written as 3 squared because 2 times 1 is 2. So we'll just call that 3 squared. Now let's look at these two things have the same bases. Correct? All right, so let's do some adding of bases. So I have the negative 1. I have 2 of them, so I can go 1 plus a negative 1. And then I can take the 3 and go 2 plus 1. Then remember, I didn't want to touch the 1/3 to the n, because that's what I'm headed towards. All right, 1 plus a negative 1 is a 0. Do you agree with me there? Oh, I'm running out of screen here. All right, so 1 plus negative 1 is 0. So do I have room under there now? So negative 1 to the 0, 3 to the 2 plus 1, 3 to the 3rd, and again, don't touch the 1 that's already in the answer. Now, what's negative 1 to the 0? 1. All right. What's 3 to the 3rd? 27. Look what I got. All right, let's do that. So, 27. 1 times 27 is 27. So I'm just going to combine that 27. And then I have negative 1/3 to the n. And there we have. Our answer equals the book answer, and I proved it. You should be able to do that. So if ever you get an answer that you really think is right and you've tested it for all of the parts, see if you can use exponent rules to get it to look like the book answer. It's a really good skill, and you really prove that you know exponents if you can do that. All right, good luck with the homework.